All right, so if you watched our last video or if you've been in class, our most recent discovery learning activity was of surface area of cylinders, but obviously this would be really too boxy to be a cylinder. So we have a rectangular prism. And as we look at this, if I asked you to find some measurements and dimensions, it would be a little difficult, especially through the screen. And there's like all of these discombobulated twists and turns. And so what I'm going to do is I'm going to work a little magic over here. And I'm going to slowly unfold this rectangular prism.
Miss Walton, that was magic.
I know. I'm a magician on the weekends.
Oh yeah.
So if you notice, so if we're looking, so I'm gonna turn it back into a rectangular prism.
Miss Walton, that was magic again.
I'm just full of it, full of magic. So if I asked you to find the area of this yellow one and this yellow one, this pink, the white, and the white, you could do that. You could even
Miss Walton,
count
I'm
squares.
colorblind.
You're colorblind? Well, I'll tell you which ones are which. So here we could count 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. So 5 times 6 we could figure out, and we could even count them individually. But that is how we are going to be looking at area of surfaces. So surface area, area of surfaces, and here we see we have 1, 2, 3, 4, 5, 6 surfaces. And there is a more efficient way that we're going to look at on our slideshow. All right, so if you noticed from that net, we had some dimensions, we had some measurements given on our rectangular prism. So what we see here is a rectangular prism with numbers on the same numbers, just in different arrangements. So in this top one, we have a 4 here. Is that right? Oh, it's the same one. Okay, never mind.
They're all the same. We're just going to show the different base possibilities.
Yes, I thought they were turned differently. Okay, so when we are needing, just like when we were looking at cylinders, it was really easy to identify the bases because they were the circles, right? The circles, either way it turned, the base was right here. It was easy to tell. And it was easy because if you were to set it down, it sits flat. But with a rectangular prism, the thing about this one is it can easily sit on any side that we go. So the thing is that's nice is that we get to pick our base, but it can get confusing if you mix things up. So I'm going to show you a couple of different possibilities of a base when we're looking at rectangular prisms. So our first option is going to be this bottom. I'm going to make this smaller. This bottom, that's still big. This bottom base here that I'm highlighting here. So if this is our base right here at the bottom, the other base, so just like the cylinder, right? Just like the cylinder, we had a base here and a base here. So same with here. So the base is going to be on the opposite side. This would be our other base. Okay? So then, if we go to this next one, we could also pick a base. We could pick this side one right here. Base right here. So it could be this one, and if we pick this as our base, our other base is going to be on the opposite side here. And there's one more option, and maybe you're seeing it before me. We could use this one's more difficult to draw, this back side here. So there's this one, and then we have this one here. So we have our 3 different options of choosing a base for this one. So more choice, but you just have to decide, right? You just get to choose whichever one you're feeling like that day. So in order to, so in our formulas that we're going to be using later, we're going to need to know these things. We're going to need to know a perimeter of our base, an area of our base, and the height. So we've determined our base. And so in this case up here, we have our base, this yellow one here. So I'm going to redraw my shape here. So if I were drawing this base, so I'm taking this and I'm putting the numbers on here. So we have a 6 kilometers, and we have this number here is also 6 kilometers. Okay, so that would be our base. Whereas if we're looking at this green one, we have 4 kilometers and 4 kilometers and 6 kilometers. So we notice with different base, we have different measurements, okay? And our last one here, if we chose this one, we would have 4 kilometers and 6 kilometers. So depending on the base that you choose, you're going to have different measurements accordingly. And so it will also change what the height of your prism will be. So if we choose this yellow as our base, then our height is going to be 4 because it's the thing that connects your 2 bases. The height is what connects your 2 bases. Over here, if we chose our green as our bases, we would have this is our base. Our height is going to be the thing that connects them, which is 6. And over here, our height, the thing that connects our 2 bases, so the orange to the orange, this one is also going to be 6. So I know that's a lot of information, but I just need you to recognize that there are different choices due to the fact that we can have different sets of bases. They could either be these 2 bases, or if I turn it, they might be these 2 bases, or these 2 bases on the side. And that changes the height, is the height being the thing that connects your 2 bases.
Thank you, Ms. Walton. So here's what we do with it all. We end up with a problem. We have a rectangular prism, and we're supposed to find the surface area. First thing I gotta do is pick a base. I'm gonna shade it with the small pen right here. I'm gonna pick this little thing on the edge right there. Okay, and then the second thing you need to do is draw your base. Every time, draw your base. Even if you don't think you need to, draw your base until you get this perfect like 20 times in a row. Then you don't have to draw it anymore. But right now, even I'm gonna draw it, and I've been doing this for years. So when I draw it, then I can put the numbers around it that belong there. This long side is 3, we can see that, and which means the other long side is 3, and then the short side is going to be 2. We get the 2 from up there, we can tell that's that little connecting number. Once I draw my base, I look at my formula, and let's pretend this time I'm going to look for lateral surface area, right there. And I look at my formula chart, and it says the lateral surface area of a prism can be found, surface area, by doing capital P times H. Well, what does capital P mean? Capital P means the perimeter. Perimeter means like walking around something. So if you're looking for the perimeter, capital P means, I think it was right back here. I didn't say perimeter of the base, but it did say perimeter. Capital P means perimeter of the base. Well, we just drew our base. Let's just walk around it. Let's start here. Here's 2 plus 3 plus 2 plus 3. Sounds like 10 to me. And so up here by my P, I'm going to put the number 10. This is like me getting all my tools ready before I use them on some project. There are some certain tools I'm going to need in my formula. I'm going to need a P and an H. So I'm going to start by drawing the base and then going and finding the numbers that belong in the formula. So I got my P, perimeter of the base, good. And then the other thing I'm going to need is the height. I need an H right here, see? So the height's going to be, like Ms. Walton told you, the distance between the bases. In this case, it's 11. So I'm going to write 11 right there. That gives me everything I need to work the formula. S equals P times H. Substitute. S equals 10 times 11. Run that out in the calculator. You will get S equals 110. Easy stuff if you draw the base and get your numbers that you need to plug in and write them off to the side. Get them organized, if you will. I call that getting your tools ready. If you're doing total surface area, it would be a little bit more complicated because now you have a P and an H and a capital B. What does capital B mean?
Area of the base.
Area of the base. And so now I'll go back and look at my drawing. See, it's so smart that you made this drawing because it's going to help you with everything. I need to find the area of this base. It's a rectangle. In order to find the area of a rectangle, you do the length times the width, or some people might say the length times the height, or whatever it is. Bottom line, you multiply the two side numbers together. So 3 times 2 is 6. So up here I'm just going to write a 6 in. And now I've gotten all my tools together. I have all the numbers I need for my formula, so I can just start writing them in. This was my formula. Capital P times H plus 2 times 6. Now, this ought to look familiar, that capital PH. It was in this formula here because to find the total area of something, you start with the lateral area and then add the top and the bottom. That's all that's happening, just like a cylinder. You learned that in the cylinder thing. So pH again plus 2 areas of the base. So that's all the way around the side plus the top and the bottom. That's what's happening in this situation. Well, that was already 110. We knew that. 2 times 6 is going to be 12. So 110 plus 12 is going to be 122. And that's how you run it. Sometimes you'll be asked to just find this. Sometimes you'll be asked to find this. And whichever thing you're asked to find, write down the formula. Go find the numbers that are going to need to be plugged in. Draw the base. And you'll be able to do it just fine. Real quick run through on this one. If we were doing this, I'd pick a base. This time I'm going to pick the one on the bottom because it's kind of obvious. It's going to be 12 and 12. 12 long, and then right here, that little gap is 3, 3, going that way, that. So 12, 3. Now, the perimeter of that is 12 plus 12 plus 3 plus 3. That's going to be 30. The area of the base is 12 times 3. That's going to be 36. The height is going to be the distance between the two bases. So the bottom base and the top base, that's going to be 6. And then I would just take those numbers, throw them into the formula, so on and so forth. Forgive the bad artwork there, but the math is true. That's how you find the lateral surface area and the total surface area of a rectangular prism.